Hi everyone. I'm going to do a short video here to show an example of how we do Karnaugh maps. So Karnaugh maps are another way that we can simplify Boolean expressions. So Karnaugh maps. And in order to use a Karnaugh map, we have to start with an equation that is in the sum of products form. And remember, the sum of products form is a bunch of ANDed conditions that have been ORed. So example, I have A bar B or A bar B bar C bar or A B C bar or A B bar C. So these conditions here are ANDed combinations that will make X equal to a high output, and they've all been ORed together. So any of those combinations will make X high. And we know how to simplify that using Boolean algebra, but now we're going to learn how to simplify it with Karnaugh maps. We notice that we have three different inputs here. So A, B, and C are the possible inputs, and each input could be either high or low. To fill out the Karnaugh map, what we're going to do is build the map itself. I'm going to put A, B going down and C going across. So C could be 0 or 1, and A and B could be 0 or 1, but since I've got them together here, I have to put in combinations. So I could have 0, 0, I could have 0, 1. Now in the next line, I might be tempted to put 1, 0, just like I do when I'm counting by binary and filling out the truth tables, but I'm not going to. I'm going to put 1, 1, and then I'm going to put 1, 0. So I've still covered all four combinations, but going from one row to the next, I only want to change one thing. So when I go from 0, 0 to 0, 1, only B has changed. When I go from 0, 1 to 1, 1, only A has changed. And then from 1, 1 to 1, 0, B has changed. And then notice looping back from 1, 0 all the way back to 0, 0, only one thing has changed again, and that's very important. And what you might see in your book, you may see it written differently, where instead of writing 0, 0, they write A bar, B bar, and then A bar, B, and then A, B, and A, B bar. And then instead of writing 0, they write C bar and C. And that's the same thing. And sometimes in that format, it's a little bit easier to compare to what we've got in the original equation. So once I've got the map drawn, then I have to put the values in the map, and I'm getting them from the original equation. So the original equation here, X equals A bar B, this first term, I'm going to circle it in blue. When I look at this term, A bar B, I can find A bar B on my map, and since there's no C in this condition, that means that it's true whether C is low or high, and I'm going to put 1s in my map for both those cases. The next term I have here is when all three inputs are low, so that's going to be this spot on the map. The next condition, A, B, C bar, is going to be here. And no sneeze. The last condition here, I'll do it in purple. A, B bar, C bar is going to be here. Once I filled in 1s into all the spots on the map that would be high, I'm going to do encirclements. And these encirclements can appear in groups of 2, 4, or 8. Now, if my map was bigger, I could do 16, etc., etc. But since my map only has 8, that's going to be my maximum encirclement. So I want to group the largest possible groups that I can. So the first group that I'm going to group is this group here, because it's a group of 4. And from that, I'm going to write part of what the output simplifies to. So from that particular grouping, I'm looking for the thing that doesn't change in that group. So looking at this group, A changes from 0 to 1, B changes from 0 to 1, but C is always 0, which is the C bar condition. So that becomes part of my output. The next encirclement I'm going to make has to cover this this little one here in the A bar BC position, but I want to make the biggest encirclement possible, and I can, you know, have groups of 1. I can circle just a single position, but that's not going to give me a simplification. So if I can circle 2 and reuse something that I've already used, I'm going to do that. So I'm going to make this encirclement, and that in that position, C changes, but the A bar B never changes. So that would give me A bar B. And this right here then is my example, X equals C bar or A bar B is the answer for this particular question. So if you were to try this question with Boolean algebra, you should get the exact same answer.